In this video, we're going to go over the electrophilic substitution mechanism that happens. So if we recall, benzene will undergo a substitution reaction with nitric acid. So the reaction here is our benzene ring, and that is going to react with nitric acid, and that's going to happen with a catalyst of sulfuric acid. So really concentrated sulfuric acid, as well as heat and reflux. There we go. Okay. And that is going to create our nitrobenzene. So NO2 here, as well as water as our other product. So this particular reaction happens through a mechanism called electrophilic substitution. So let's take a closer look at this actual mechanism. Now, this particular mechanism happens in three kind of steps. The first step is we need to generate the electrophile, which is called a nitronium ion, or NO2+. And the reason we need to generate it is because pure nitric acid only has a very small concentration of NO2+, but by mixing it with sulfuric acid and some heat, it's going to generate a higher concentration of our electrophile. So this particular step here, it's not really a mechanism, it's just a reaction where we take our nitric acid and our sulfuric acid with a bit of heat, and we generate our NO2+. We also generate water as well as HSO4-. And that HSO4- is actually used in a later step in this mechanism. But this is really the point of step number 1, is to generate lots of this nitronium ion. Step 2 then is where our delocalized pi electrons are going to attack the electrophile that we just generated. This is our rate determining step. And the way we show this attack is we take these delocalized pi electrons here in the ring, and we attack our electrophile, and that's going to create this intermediate here. So we show it by a half circle because we've kind of broken apart one sort of set of those delocalized pi electrons. So we show sort of a half ring with a positive charge there to show the carbocation that's being formed. And we also then have NO2 and H that are attached here. And this carbon-hydrogen bond is then broken, and those electrons that are in that bonding pair are put back into the ring to generate our final product. Now, this actually happens with the HSO4 ion that we generated in step 1. So let's take a little bit closer look at what happens from here, from this intermediate to our final products. And so that's step 3. If we take our HSO4-, one of the oxygens is going to act like a nucleophile. And so that's going to attack our hydrogen, which is then going to break that bond. And so it generates our final product, and then it regenerates H2SO4. So this is why H2SO4 is a catalyst, because we use it in step 1 and it's regenerated in step 3. So it never is actually consumed. It's just, shifted a little bit in terms of its form, but then always regenerated at the end of the mechanism. So that's it for this video. We'll see you in the next one.